Hello, everyone. Welcome to my channel today. We'll be talking about how to ace a geometric distribution questions in our A-level exams. Okay, so if you like this video, if it is useful for you, I suggest you hit the like button. If it's not good, hit the down button for us. And you should subscribe to the channel. Tell your friends, maybe they will like it. Right, so to start, first we need to know what geometric distribution is. I assume you know by now, but let me give you the shortest definition that will help you. If a distribution follows the idea that there is supposed to be maybe some form of failures before there's a success, okay, then that's definitely going to be a geometric distribution. For example, if you are to throw a die, okay, and I ask you that get a 6. So how many times will you throw the die before you get a 6? Maybe you threw the die 4 times before you got a 6. So that means that you did not get a 6 in your first 3 throws before you got a 6 on the 4th throw. Okay, so you failed 3 times before you actually hit the target, and that is what we call a geometric distribution. It's a new thing in the syllabus, and as such, expect questions on that. All right, so I have compiled questions on geometric distribution. The thing is that it's really difficult to get questions on this particular distribution. So we have a really small sample size from November 2020, the paper 515253. These are the questions that I have, and I'm about to solve with you. It's my calculator. Let's go through one by one. Okay, I will make the worksheet available down the link, so you can also download it, and while you watch it, this particular video, you also go along with it. Right, so the first question says that this is, let me see, 5-3 October November 2020, 5-3. It says an ordinary die is thrown until a 6 is what obtained. Okay, so that means that we are going to maybe fail a number of times before 6 is obtained. Find the probability that obtaining a 6 takes more than 8 throws. So let's say that the distribution is x. Okay, so the probability of x is greater than 8. Okay, because they said that it is more than 8 throws to get your first 6. Okay, so what does that mean? Well, basically it means that you are going to fail 8 times because you get the 6 after the 8th throw. Okay, so that means that q raised to the power 8, where q is the failure, okay, p is the success. Now from the account, the probability of you getting a 6 on a fair die is what? 1/6, right? So the probability of success is actually 1/6. So that means q is 1 minus 1/6, giving you 5/6. Great. So that means that the answer is 5/6 raised to the power 8. And you can put that on your calculator for 2 marks. 5/6 raised to the power 8. And that gives you 0.23. I'll write 0.233. Okay, correct with 3 significant figures. All right. Then let's consider the B part of the question. It says that 2 ordinary fair dice are thrown together until a pair of 6 is obtained. Okay, so now 2 dice. Okay, 2. Be careful. Until a pair of 6 is obtained. Find the number of throws taken. The number of throws taken is denoted by the random variable x. So now we have to find the expected value of x. Now, when they say expected value, they're actually talking about the expectation or the mean. Okay, and the formula for geometric mean is basically the mean of, let me just write into bracket the mean. Okay, the mean will definitely be 1/p. Okay, the mean is 1/p, where p is the probability of success. So ask yourself, if you have a die, okay, 6-sided die, one against the other, you have a total sample space of 36, but for you to have a pair of 6, okay, 6, that's actually 1 out of 36. Okay, so that's the probability of success. So for a 6, you have, so probability of success is 1 over 36. Therefore, you just put that over there. So we have 1 over 36, and I believe the answer is 36. Okay, so that is the mean. Now the question goes ahead to say that find the probability that obtaining a pair of 6 takes either 10 or 11 truths. Now in probability, when you hear or, you are going to add. Okay, keep that in mind. So we are going to do, it takes either 10 truths or it takes either 11 truths, and then we add the two probabilities up. Okay, so let's start with it taking 10 truths. Okay, so you are going to obtain a 6 when you take about 10 truths. Okay, so the argument is that the first 9 truths you actually fail, then on the 10th truth you have a success. So that means, and if the success is 1 over 36, and the failure, the Q, is actually 35 over 36. Okay, because 1 minus 1 over 36. So that means that on the 10th truth, so you're going to fail 9 times before there's a success. So the probability of x equals 10 would be q to the power 9. Okay, you're going to fail 9 times before there's a success. So that means 35 over 36 to the power 9 times 1 over 36. Okay, then we also told of, so let's check this probability before we even continue. Or we should just keep it like that. Okay, then we also told that or in the 11th. Okay, so that x equals 11, that would mean that we are supposed to fail like 10 times, and then on the 11th we have the success. Okay, so that means q is raised to the power 10, and then we have a success. That's the 11th observation. So that means we have 35 over 36 to the power 10, then 1 over 36. Great. So now they used or, so now let's add the two up. So that would mean that we have 35 over 36 to the power 9, okay, times 1 over 36 plus, also plus 35 over 36 to the power 10 and 1 over 36. Great. So we can put all of this on the calculator. So we have 35 over 36 to the power 9, all right, times 1 over 36 plus we have 35 over 36 to the power 10 times 1 over 36. Great. So our answer is 0.043. That is if you correct it to 3 significant figures. Okay. So that is the question that came for paper 5.3. Let's move on to the next one. Let's see. That's paper 5.2, October, November 2020. Okay. So it says that a fair-sided, six-sided die with faces marked 1 to 6 is thrown repeatedly until a 4 is obtained. Okay, well, we should find a probability that obtaining a 4 requires fewer than 6 truths. So let's say that the whole distribution is defined by x. Okay, so the probability of x is less than 6 truths. Okay, all right. Now whenever you are dealing with this, think of it this way. You are going to actually get a 4, okay, within 6 truths. It's less than 6, okay? So that means that, well, the success could have been the first truth, could have been the second, could have been the third, could have been the fourth, could have been the fifth, okay? Any of these could have been, I mean, and we don't know exactly when we got a 4. So we use the reverse thinking to help us to go about it, okay? Because if you actually say that it is less than 6, then it means that 6 is not included, right? So that means it's from the beginning up to where 5. Okay, so let's do the probability of x is less or equal to 5. Now this will rather make sense for us. Okay, now if you want to find this probability, why don't you just do 1 minus. Now, minus something, but what is that thing? Think about it. You are going to have your success on any of these. Okay, so normally the shortcut that we do is 1 minus q raised to the power 5. Okay, where q is the failure. Okay, when you do this, you capture all the possible situations where the 4 could have been obtained, whether the first one, the second, or the third, or even a fifth through. Okay, we don't know when it happened, so it's very important to quote this formula, all right, that it must have happened within this range. Okay, so we don't know our P, we don't know our Q, so let's get that from the information. Now you have 6 phases, so the probability of getting a 4, okay, is 1 over 6. Therefore, failure is 5 over 6. Great. So we have 1 minus 5 over 6, all to the power 5. All right, so you can put this on the calculator. So that's 1 minus 5 over 6 to the power 5. And that is 0.598. That is correct to 3 SF. Okay. All right. Now let's consider the B. It says on another occasion the die is thrown 10 times. Okay. Find a probability that a 4 is obtained at least 3 times. Now that is quite interesting. Once the die is thrown about 10 times, okay, from the beginning to about 20, if I have an observation that is maybe from 1 to 20, that observation is more likely to follow what we call a binomial distribution. Okay, so be careful here. It says find the probability that a 4 is obtained at least 3 times. Okay, whenever you are working a geometric question, normally they don't tell you the number of times that the definite number of times you don't get it. For example, from the previous one, we were told that well, it's fewer than what? 6. That's it. They didn't say it's 6 or it's 5, it says it's fewer than 6. Now they are telling us that the die is thrown 10 times, so that means n is 10. Whenever you are given n, okay, be careful, that is definitely going to follow a binomial, because it's either you get a 4 or you don't get a 4. That is it for binomial. Okay, 2 outcomes, success or failure. And we have already argued that the probability of you getting a 4 is actually 1 over 6. So the probability of you not getting a 4 is 5 over 6. And now they said that you are going to throw it at least how many times? 3 times. So that means that this distribution now follows a binomial with n of 10 and a probability of success to be 1/6. Okay, so that's it. Be careful. If this were to be geometric, you would have known, because they would have maybe made a claim that it was, a 4 is obtained and it's, so maybe more than 3 times, like the previous question that we did. They wouldn't have told you that they threw it 10 times. That n wouldn't have been given, okay, for a geometric. But now that they have given this n, be careful. That is a binomial that has been set way beneath a geometric. So you should know your distributions very well. If not, this is going to beat you. All right, so now they said it's less than 3, okay? Sorry, at least 3. So you are going from 3 to 4 to 5 to 6 to 7 to 8 to 9 and to 10. And that is a lot of work that I cannot do. Therefore, I'll do the flip side. I'd rather do 1 minus the thing is less than 3. Okay, that is a smarter way to go about it. So probability of x is, when we say at least 3, is greater or equal to 3. So I'd rather do 1 minus the probability of x is less than 3. And if it's less than 3, it means I'm looking at 1 minus the probability of 0 plus the probability of 1 plus the probability of 2. Okay, all right. So this is a good way to go about it than to do 3, 4, 5, 6, 7, 8, 9, 10. You are writing against time, so you cannot just afford those things. Okay, so let's get these ones down. The probability of 0, so that's n is what is 10, so we have 10 combination 0. Probability of success is 1 over 6, and then failure to the power 0, and then failure is 5 over 6 to the power 10, plus now we have 10 combination 1, we have 1 over 6 to the power 1, 5 over 6 to the power 9, and then we have plus 10 combination 2, 1 over 6 to the power 2, and then 5 over 6 to the power 8. All right, so let's check this out. You know, in the exam, don't put everything on a calculator, okay? But this is no exam. This is a YouTube channel. So I would actually put everything on a calculator to save us time, okay? We don't want to do lots of things, and then we have a lot of things to do in our lives. All right. But in the exam, please do it in bits, okay? So, but this, I'm going to put everything on a calculator. Now, 1 over 6 times 5 over 6 to the power 9. Then finally, plus 10 combination 2. 1 over 6 to the power 2 times 5 over 6 to the power 8, right? Oh, see, it's not even working. My calculator can't afford to give me everything. Okay, so that means that I'm going to get the first 2, then later on include the last guy. Okay, so the first 2 gives me alright, this calculator, why are you behaving like that? Okay. All right. So I get 0.4845. Okay. Plus, now let me check the last one. 10 combination 2. 1 over 6 to the power 2 times 5 over 6 to the power 8. And that gives me 0.2907. I'll add it to the answer. I got 0.4845. Now we have 0.7752. Okay, now we said that 1 minus, okay, therefore we can just do 1 minus our answer. So 1 minus answer on the calculator, that gives me 0.225. 3 significant figures, okay? And now you are good to go. So that's it. Be careful. The question started with geometric. Okay, they said fewer than 6. I mean, you got your success in less than 6, so that's great. And now the second part, they give us the n. Okay, be really careful. They give us n, which is 10. And then we know the probability of success. We know the probability of failure. These are the conditions for binomial. So definitely it's a binomial question. All right, now let's look at the next one, which is 5-1 October, November 2020. Says that Kayla is competing in a throwing event. A throw is counted as a success if the distance achieved is greater than what? 30 meters. The probability that Kayla will achieve a success on any throw is 0.25. So we'll find the probability that Kayla takes more than what? 6 throws to achieve a success. In fact, this is similar to one of the questions that we've solved in there. So let's say that the throw follows, it follows a geometric, and then X represent the throws. Now she's going to have her first success, okay, achieve a success when she throws more than 6. Well, that means that she might get the success on the 7th throw, okay? So that means that she's definitely going to fail about 6 times. So Q raised to the power 6. So that means that, remember they said that the success is 0.25, so the failure will be 0.75, so 0.75 to the power of 6. Great. So let's grab our calculator, 0.75 to the power 6, and that is 0.178. That is 3SF, okay? Now the B part says that, it is quite interesting. Okay, it's similar to the one that we solved earlier. It says that find a probability that a random sample of 10, I don't know why they keep saying 10, they could have chosen 15 or something, Killer achieves at least what 3. So this is a mean exact replica. Like I said, it's something new in the syllabus. So I mean, it's how they ask the question. These are ways they would go about it. So you follow through my presentation. I mean, you go through the worksheet. You'll be great. You go to the exam room. They'll bring something similar. Okay. All right. So now we know n is 10. We know the probability of success is 0.25. The question gave us. So the failure is 0.75. All right. And now they said that these are conditions for binomial actually. So at least 3, it means 3 and above. So I'm rather going to do 1 minus below 3. Okay. So x actually follows a binomial with n of 10, probability of success 0.25. So I'll do 1 minus below 3. So 0, and then I'll do 1, and I'll do 2. Okay. All right. So let me work on the 0, 1, 2, and then add them up, and I'll be good to go. So that's 10 combination 0, the first one. Probability of success 0.25 to the power 0, 0.75 to the power 10, plus 10 combination 1, success 0.25 to the power 1, failure 0.75 to the power 9. Okay, yeah, the difference. Then I have 10 combination 2, 0.25 to the second power, and then 0.75 to the 8th power. Okay, so like we saw in the first example I did, not everything will go on the calculator. So let me do it in bits. So I have 10 combination 0 times 0.25 to the power 0. Okay, times 0.75 to the power 10, 0.75 to the power 10. Okay, plus then I have 10 combination 1 times 0.25 to the power 1 times 0.75 to the power 9, and those first two should give us 0.2440. Okay, plus now let me do the last one, 10 combination 2 times 0.25 to the second power times 0.75 to the 8th power, and that gives us 0.2816. Great. So everything would be, so this thing plus 0.2440, 1 minus answer, and that gives us 0.74474. Okay, good. That's great. Yeah. Now the next one is a question from which 51 MJ 2020. Okay. It says that the score when two fair six-sided dice are thrown is the sum of the, I mean, blah 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 on the faces. Okay. So when you sum, that is the score. You should look for the probability that the score is 4. We are going to get this. Okay, that's quite interesting. Normally, I would advise that you get, I mean, if you don't know how the whole thing is going to be, then you should get something like this. Okay. This is 1, this is 2, this is 3, this is 4, that's 5, that's 6. Okay. And then you get something like 1, 2, 3, 4, 5, 6 as well. Okay, you are interested in getting what? A 4. Says that the score is what? Is 4. So we are not going to do the whole thing. We are just going to use our eyes to do the rest. So if we are going to get a score of 4, then it means you are going to get, remember that we believe the score is the sum. Okay, so 1 and 3. So 1 and 3, when you add this, you get 4. And that's it. And then 2 and 2, when you add 2 and 2, you get 4. And then what else can you get 4? I don't think there's anything here again. Now 3 and 1 will also give you 4. And then that's it, right? What else? 4 and something, no, 4 and nothing will give you 4, except 0. 0 is not part. And that's it. So you have about 3 cases, okay? But the entire sample is 6 times 6, so that's 36. So let's give it a try and see. So the probability of getting a score of 4 is actually 3 times, so it's 3 out of 36. And 3 over 36 is 1 over 12. Okay, so that is what they wanted. So you don't really have to do the entire table. You just, do a little thing and then think about it. They said that the sum, so you deal with when you can add the 2 to get a 4, and you are good to go. Okay, so now we know that we are correct because we decided we should show that it's 1 over 12. Okay, now the B part said that 2 dice, okay, are thrown repeatedly until a score of 4 is obtained. And now we already know what gives us a score of 4. We know a score of 4, the probability of success of you getting a score of 4 is actually 1 over 12. You know that already. So that means that the probability of you not getting a 4 is 11 over 12. Okay, now they said that we should use X, okay. Now, the first thing says, find the mean of X. So it's either they ask you to find the mean of X or the expected of the expectation of X. Okay, so these are wordings that they use, so look out for them. Excuse me. So now I told you that the mu, or the expectation of X, is actually 1 over P. And we know P is 12, it's 1 over 12, so that means we have 1 over 1 over 12, and I think your answer should be 12. Okay, let me verify that just in case, you can't be too careful. Yeah, that's 12. Great. For 1 mark, you are good to go. The next one says that find the probability that the score of 4 is first obtained on the sit-through. It's actually obtained on the sit-through. Okay, so that means that the probability of X equals 6. Okay, now if we are going to obtain the 4 on the sit-through, then that means that you must have failed on the first 5 throughs, okay, so that you have your success on the sit-through. So that means Q raised to the power 5, and then there's now your success. And now we know that your failure, which is Q, is 11 over 12, so to the power 5 times your success, which is 1 over 12. All right, so this one, just put it on calculator, don't think too much. 11 over 12 to the power 5 times 1 over 12. Okay, according to my calculator, the answer is 0.054. Okay, 3 significant figures. All right, now the last one says that probability of X is less than 8. So it means when you have probability of X is less than 8, that means that the success must have been from the 1st to the 7th, since it says less than 8. Okay, so X is less than or equal to 7. Okay. All right, so if this is the case, then use the shortcut 1 minus Q to the power 7. Okay, so 1 minus Q to the power 7. And that means 1 minus 11 over 12 to the power 7. I put everything on a calculator for 2 marks. 1 minus 11 over 12 to the power 7. And that is 0.456. Great. Okay, what else do we have here? Another year, they said that a pair of fair coins is thrown repeatedly until a pair of tails is obtained. So now the argument is that you want to get a pair of what? Tails. Okay, a pair of fair coins, so 2 pair. Now you want to get a tail, a pair of tail, TT. Okay, the random variable X denotes the number of throws that's required to, that's fine. But now think about it. If you have 2 coins, what are the sample space? Well, you get head, you get head tail, you get tail head, and you get tail tail. These are the possible things. So if we're going to get a pair of tails, then that's 1/4. Okay, so the probability of success in this case is 1 over 4. Well, the question is actually looking for the expectation. Okay, the expected value. That's the same mean. What they're actually saying is that find the mean of it. And we know the mean is given as 1 over P. Therefore, you have 1 over 1 over 4 giving you 4. Okay, like that. Right, then it says that find the probability exactly 3 throws are obtained to get a pair of tails. Okay, you are going to throw exactly 3 to get a pair. So that means that you're actually getting it on the 3rd throw. You are going to get 3rd throw. Because when you try the first time, that wasn't the case. Second, that wasn't the case. But no, exactly on the 3rd throw, You got it. So that means you failed twice before you had your success. So probability of x equals 3 is exactly 3. It means that I'll fail twice before I have a success. Okay, so that means what our success, we got 1/4, so the failure kill is definitely 3/4. Okay, so that means 3/4 to the power 2 times 1/4. Just grab a calculator. These things I don't use my head. I have a lot of things to think about, so I'll use my brain to do those stuff. So your answer is 9/64, or if you want a decimal, you can just write 0.141. Okay, 3 significant figures. Okay. Then the C part is quite interesting. It says that find the probability that fewer than 6 truths are required to get. So it's a fewer than 6 truths. So x is less than 6. Great. So that means that actually it is x is less or equal to 5. Okay. If it's less than 6, then it's less or equal to 5. If it's less or equal to 5, then we believe that you can use the shortcuts 1 minus q to the power of 5. And that would be 1 over, we know q, that's 3/4. 3/4 to the power of 5. All right, and that, just grab your calculator and then you'll be fine. 3/4 to the power 5. Great. And that gives you 781 over 1024. Those of us who like to write in decimals, 0.763. Okay, 3SF, and you are good to go. Well, that's good. This is actually the last style of question that they can ask. Normally for geometric distribution, they will tell you to find the expectation, or it's more than 10 truths or 6 truths, whatever truths, more than, okay? So that one, you just deal with the probability of failure that Q is raised to the power, whatever they are talking about. And then they will also ask for less than, okay? So they will say that, maybe it's just less than, or they will say it's something to denote it's less than. And the last one is what we call the approximation. Now, for approximation, for S1 statistics, we normally use the normal distribution to approximate these things. So if you haven't done normal distribution, then the last part of this question will be quite a bit interesting for you. When I say interesting, I mean difficult, because I need your knowledge on normal distribution to do that. Okay, so I assume that you've done normal distribution. If you haven't done it, then this is enough. I mean, what you've watched so far is enough. Just forward this part of the video and go to the next question and continue with it. When you do normal distribution in school, or you can watch my video on normal distribution, then you come back and then you enjoy it. Okay, so now I assume you've done normal distribution, so let's go about it. Now for normal distribution, since they said use an approximation, okay, let me use this opportunity to solve so many questions, okay, or issues with you. For S1, whenever they say use an approximation, use a normal distribution, it's always a normal distribution, because you cannot use the discrete random variable to approximate a binomial. You cannot use a binomial to approximate discrete random. You cannot use geometric to approximate a binomial, or a binomial to approximate a geometric. Now listen, all these distributions, when you increase their sample size, they tend to follow the normal distribution, the bell shape. So when the sample size is more than 20, it's normal distribution, okay? So when you take a look at this question, they are saying that on a different occasion, a pair of fair coins is thrown 80 times. Just look at it, 80, more than 20, okay? Says use an approximation to find the probability that a pair of tails that's obtained is more than what? 25 times, okay? More than 25. Okay, now just like the way we solve approximation questions relating to binomial, the same tricks, the same techniques are things that we do over here. Okay, so now we know n is 80, and now for this we know that the probability of success is 1/4 getting a pair of tails. So, and we also know that failure is 3/4. We have already established these things now the next thing that we want to do is to, since they say use an approximation, actually, well, it will satisfy the condition, but I don't know, some examiners are just too much. So you have to show that NP is greater than 5 and then NQ is also greater than 5 before you can actually start to do that. So this implies that, let's say 80 times 1 over 4, that's 20, I believe so. I could be wrong, or yeah. Sometimes I just want to use calculator and be free. Yeah, that's 20. Then we have 80 times 3 over 4, and that would be 60, right? All right, so we know that both are greater than 5, so we can use approximation. Well, the question says use approximation, so just use approximation. You don't need to worry yourself about this conditions that you must satisfy. But just move on. Unless you want to be very, very critical about everything in the exam room, then that's fine. Okay, so the NP is actually your mean. Okay, you need a mean. That's the NP, and you found it is 20. Great, don't waste time to do it again. Now you need your standard deviation, but you can get that from the variance, and variance is NPQ. Okay, so that's 80 times 1/4 times 3 over 4, and that will be 80 times 1 over 4 times 3 over 4, and that is 15, right? Great. So now what happens is that they said it is more than what? More than 25. So that's quite interesting. So P of X is greater than 25. Now we need to correct the discontinuity in it. So in statistics we call it continuity correction. It's nothing big. They are saying it's more than 25, so just add 0.5 to it. If it's less than 25, you subtract 0.5 from it. Okay, more than 25, you add 0.5. Is less than, then you subtract 0.5, and you're good to go. All right, so that means that the probability of Z, okay, if we are going to normalize this, is going to be 25.5, okay, because they said more than. So 25.5 minus the mean, which is 20, divided by the standard deviation. But remember, you have a variance of 15, so you can not have a perfect number when you take the square root of that, so just maintain square root 15. Please don't put 15 there. If you put 15 there, that means that you are working with a variance. But the formula, I believe you have done normal distribution at this stage. If you want to standardize anything, it's x minus mu divided by standard deviation, okay, not divided by variance. So you have to take square root of the 15. Great. Let's continue. So that means that Z is greater than what? Let's see. Grab your calculator. 25.5 less 20 divided by root 15. And that would give you 1.420. So, something like that. Now, for Z greater than such a value, you just do 1 minus phi of the value over there. And so let's see. Phi of that value, I think I have this is the book I use. Okay, Nelson Mathematics. Okay, so let's read that value. 1.42. It will be in your formula book, so don't think about how to get it. 1.42 is this. So your answer is 0.42. Great. So 0.9222. Okay, so 1 minus 0.9222, that will give you 0.0778. Okay, that's what they want. So if we use an approximation, then getting the probability of you getting more than 25 is actually 0.0778. Okay, let's consider this one. Okay, says that 40 members of a club include Ranaf and Saeed. All 40 members will have to travel to a concert. Find the number of okay. This I'll cancel it out. this is for permutation and combination. So, okay. Well, there's a question here, yeah. That must have been the reason why I included this particular question here. Okay, so this says an ordinary fair die is thrown repeatedly until a 1 or a 6 is obtained. Now, that is quite interesting. It's not just a 1 is obtained, either 1 or 6. So, all there means you are going to add a 2. Okay, that is very, very important. Find the probability that it takes at least 6 trues. At least 3, but no more than what? 5 to obtain your 1 or 6. So, let's represent the first part, okay? The probability of at least 3 and then no more than 5, okay? So that's the probability of x is going to be greater or equal to 3, but not more than 5. So, okay, so they are all going to have the or equal to sign attached, because at least means from there going, but no more than 5 means it could be 5. It could be 5. Okay. All right. So before we solve this, we need to know the probability of success. Okay. The probability of success in this case. Now, our success, if you have a fair coin, a fair die, you getting a 1 is actually 1 over 6. And then you getting, they said also plus a 6 is also 1 over 6. So that means that the combined success is going to be 2 over 6 or 1/3. Okay? All right. So now let's check this out. If we are going to get, okay, good. So let me just bring this one sideways, maybe here, and bring this guy down. Okay. All right. So now the question says that it is at least 3, okay, but less than this. So if you are to list this thing out, it means you have the probability of x equals 3 plus the probability of x equals 4 plus the probability of x equals what? 5. So these are the things you are looking for. So now let's do the x equals 3. Okay, so that means that you had your success on the third true. That means you must have failed on the first two. Okay, so that is Q square and then P. Now the fourth true means that you failed 3 times before you had your success. The last one, you failed 4 times before you had your success. Okay, now we know that the success, we have already found that is 1/3. So that means the failure is 2 over 3. Okay, so we have 2 over 3 square times 1 over 3 plus, then this one would be 2 over 3 to the third power times 1 over 3. Finally, 2 over 3 to the fourth power times 1 over 3. Great. Let me put everything on a calculator. Okay, 1/3 plus. Now we have 2 over 3 to the third power times 1 over 3. Then finally we have 2 over 3 to the fourth power times 1 over 3. Great. What is the calculator saying? 76 over 243 or 0.313. Good. That is correct to 3 SF. All right. So this is how to go about it. That statement is really, really important. It said at least 3, but no more than 5. So that means 3, 4, and 5. Okay. Good. Right. The next thing that we want to do is that they said that, okay, on another occasion, the die is thrown 3 times. Okay. The random variable x is times that you get 1 or 6, and we have already found that. It says draw a probability distribution table. Okay. So now think about this. You are going to throw something 3 times. Now, it's possible that in all the 3 truths, you might not even get a 1 or a 6. So that means that, remember they said X stands for the number of times you will get a 1 or what? A 6. So it's possible you will not get any. So that means that if I'm to draw my table for X, okay, X could be 0. Because it says the number of times that you will get 1 or a 6. So if I don't get any, then, we know that that's 0. So it's so possible that you get one of it, okay, just once, or you get twice or the third time. Okay, so it's possible that you will not get any of them. It's possible that the first true you will get either a 1 or a 6. Or it's possible that the first true you will not get anything. The second true then get 1 or a 6. So it's also possible that the third true is when you actually get a 1 or a 6. That means the first 2 truths you don't get anything. Okay. Now when we say probability distribution table, it's just the distribution against its probability. Okay. So against its probability. All right. So let's get this down. You need to show working for this part. Even though you've prepared the table, you need to show working and then fill in those values. Okay. So now for 0, that means that probability of X equals 0. That means that in all the 3 truths, okay, you couldn't get any of these. Okay, so that means that K raised to the power 3. And we have already established the fact that K is 2 over 3. Okay, since the probability of that particular success is 1/3. So that means you have 2 over 3 to the power 3. And that will give us 2 over 3 to the power 3. That is 8. Let's use black. 8 over 27. Okay, so the probability of X equals 1, that means that the success happened on the first true. Okay, so that is definitely 1 over 3. Okay, that's the success. It means there's no failure. Okay, then we have X equals 2. Now, for X equals 2, that means that you had a success on the second true. That means you must have failed on the first true before you got the success. So that's QP. So that's 2 over 3 times 1/3. And that would be, let's see, 2 over 3 times 1 over 3. That is 2 over 9. 2 over 9. Okay, then finally you have X equals 3. Well, that means that you must have failed 2 times. Okay, the first 2 you must have failed, and then on the third true you got your success. So that's Q raised to the power 2 times P. Okay, and that would be 2 over 3 square times 1/3, and that would be 2 over 3 square times 1/3, and that is 4 over 27. Normally when you finish with your probability, we believe that the sum of all probability should be 1. So let's give it a try. If it's not 1, then we are wrong. So that's 8 over 27 plus 1 over 3 plus 2 over 9 plus 4 over 27. And then, ladies and gentlemen, when you give that a try, you see you will get 1. That means that your table, what you've done, is actually correct. Okay, so that's it. And then down there, says find E into bracket X. What that actually means is that find the expectation. So this is the expectation or the mean, okay, that they want you to find. Now the mean is basically, okay, let's go and copy this guy. So if you take the table, what you want to do is that, let me paste it here too. Great. So what you want to do is to take each of the X values, okay, and you multiply by their various probabilities and you sum them up. That will give you the mean. So that means you have 0 times 8 over 27 plus, then you take the 1 times its probability 1/3 plus, and then you take 2 times its probability 2 over 9. Then finally 3 times its probability 4 over 27. Okay, we can put these things in brackets so that they look nicer that way. Okay, so the first part is actually 0, so you don't need to think about it. And 1 times 1 over 3 is just 1 over 3. So the next thing is you have 2 times 2 over 9. And that would give you 3 times, so you have 4 over 27. Great. So the expectation in this case is 11 over 9. Or if you want to write that in decimal form, then that is 1.22. That is correct to 3 significant figures. So that's how to go about it. Just take, so if you want a formula, I can just give you a formula from there. All right. So the expectation is definitely the x value. So let's say x1 times its probability plus x2 times its probability plus x3 times its probability, and so on and so forth. So that's how it works. All right. Then let's see. So this is the end of our